Hey friends, so today we're talking about identifying whether ratios create a proportion. What's important to remember is that a ratio is just a relationship between two numbers. Any fraction can be a ratio. And a proportional relationship exists between two ratios when the ratios are equivalent, means they're equal. Now, there's a lot of different ways we can go about determining whether two ratios are equivalent. We can find a common denominator. Those of you from Texas and Butler will know, Mr. F is really big on solving the division problem. So any fraction is just a division problem we haven't solved yet. But the way we're going to talk about today is by creating a table. So let's take a look at this first problem here. It says, do the ratios 1/2 and 9/18 form a proportion? What I'm going to do is create a table. Say 1 for fraction 1 and 2 for fraction 2. I'm going to put 1 and 2 in my first column. This is fraction 1, and 9 and 18 in my second column. And what I'm going to figure out is this third column of multiplication. What do I multiply 1 by to get 9? Well, we know that 1 times 9 equals 9. So I multiply 1 by 9. What do I multiply 2 by to get 18? Well, if I multiply 2 times 9, 2 times 9, I get 18. This is a proportional relationship because the number that I multiply 1 by to get 9 is the same number that I multiply 2 by to get 18. In this case, that number is 9. Some of you might remember this phrase. This number is called our constant of proportionality. Now, you don't need to know that in order to solve these specific problems. You could also look at 1/2 and 9/18 and realize that 9/18, I can divide top and bottom by 9 and get 1/2, and 1/2 equals 1/2. Or you could have gone a little bit more convoluted and said, hey, a common denominator between 2 and 18 is 6, and 1/2 is going to be 3/6, and 9/18 is going to be 3/6, and that works. But the reason I'm having us solve the problems this way is that when we get to more complicated problems a little bit later in the week, knowing how to set up a table like this and knowing how to look for this constant of proportionality is going to be very, very helpful. Let's take a look at another example. We have 8/9 and 1/6. So I've got two ratios, and I'm going to list 8 and 9 here, and 1 and 6 here. And going from here to here is going to be hard, because what do I multiply 8 by to get 1? It's more of a division problem. So I'm going to go the other way. I'm going to say I multiply 1 times 8 to get 8. So what I'm looking for is this number, this constant of proportionality, to be the same for 6 and 9. Well, what happens when I multiply 6 times 8? Do I get 9? 6 times 8 equals 9? No. 6 times 8, excuse me, is of course 48. So this is not a proportional relationship. I guess this is kind of confusing. I should circle these, shouldn't I? Let's take a look at this third one. Now, I've been listing the fractions listing these by fraction. But you don't have to do that. You can also, if you want, say, let's do numerators and denominators. So my numerators are 8 and 3. So I started with this fraction here, so I'm going to keep going with that fraction. Denominators are 12 and 2. And the exact same process will apply. What do I multiply 8 by in order to get 12? Well, this is a little bit more complicated. 8 times what equals 12? Well, I can solve this like I would any equation. I can divide both sides by 8 and get this question mark is 12 over 8 or 3 over 2. So what I want to know is, do I multiply 3 times 3 over 2 to get 2? 3 times 3 over 2, does that equal 2? Well, remember, 3 is just 3 over 1, and I multiply straight across. 3 times 3 is 9. 1 times 2 is 2. And so my answer here is 3 halves, not 2. So this relationship has a different constant of proportionality than this relationship. And because they have different constants of proportionality, they do not form a proportion. Your focus is on this number here. Do the ratios, does the table, do your data have the same constant of proportionality?